This video is an excerpt from the ϕPPL programming language training series. This series will be made available for purchase on DVD in its entirety. Copyright 2011, Technoventure Incorporated. Assignment operators. It is difficult to talk about assignment operators without talking about statements. In one way or another, all executable statements exist because they, at least potentially, cause a change to take place. And in programming languages, most changes take place through assignment statements. While there is only one assignment operator in virtually all programming languages, the ϕPPL programming language actually has several. In Phi, the assignment operator that is equivalent to the only one provided in other programming languages is called the left overwrite assignment operator. This symbol looks like the one shown. As you can see, it is pointing to the left. Here is an assignment statement in Phi. As in C, virtually every executable statement is terminated with a semicolon. The source expression to the right side of the assignment operator is evaluated first. The result of this evaluation is assigned to the destination on the left side of the symbol. This operator is like the one in C for several reasons. First, its precedence is very low, so that most operations can be used in the source expression without having to use parentheses to control order of operation. Secondly, the assignment itself returns a result that can be further used as part of a larger source expression. This feature makes it possible to write a value that is computed from a single source expression to multiple destinations. The type and value that is returned from an assignment operation is always a copy of the type and value that was written to the destination. Another very powerful operator in Phi is the left read before write assignment operator. It looks very similar to the left overwrite assignment operator, but it also has an input or read arrow at its tail, as well as an output or write arrow at its head. Both of these arrows point in the direction of data flow. This operator's precedence is the same as that of the left overwrite assignment operator. The source expression to the right of this operator is evaluated first. What makes this operator different from the overwrite assignment operator is that the destination is read first before being overwritten by the value computed from the source expression. It is the original value read from the destination that is returned from the assignment operation. The subtle difference of the read before write assignment operator has very powerful consequences. What it means is that values can be shifted through a number of specified items. In this example, the value of 4 is written to C. But before this is done, C's value is first read to be returned from the assignment. It is C's original value that is written to B. But before this is done, B's value is first read and is returned from the assignment. Next, B's original value is written to A. But before this is done, A's original value is read and is returned by the assignment operation. Finally, A's original value is thrown away because it is not used in a subsequent operation. The net result is that the values are shifted between variables to the left. If A also appears as the rightmost source expression, which is evaluated first, all of the values will be preserved, but they will be rotated between variables. Note that if you have only two variables, this operator can be used to swap their values without using a temporary variable, which is necessary in other programming languages. The swap assignment operator is a convenience that facilitates the exchange of two variables' values in one statement without having to use a temporary variable. As you recall, the left read before write assignment operator can also do this, but the swap assignment operator is simpler to use and more obvious in its intent. In a swap assignment, values on both sides of the operator are both sources and destinations. When this statement is executed, the operand to the right of the assignment operator is read first, then the one to the left is read. This second value is then written to the operand on the right. Finally, the first value that was read from the right is written to the left operand. It is this value that is read from the right and written to the left that is returned by the assignment operation. Both the left overwrite and the left read before write assignment operators have dextral counterparts. These are the right overwrite and the right read before write assignment operators. These basically have the same functionality as their sinistral counterparts, but with two exceptions. First is that the precedence is much higher. Second, the source expressions are on the left side of the symbols, while the destinations are to the right side. The arrows still point in the direction of order of evaluation. These right assignment operators were provided so that inline forced conversions, also known as coercions, could be made more easily. Assignments and coercions can both be done using either left or right assignment operators. Just remember that they have different precedences. Here we coerce the value read from source to the data type of dest. If dest is a type instead of a variable or other writable datum, then the result of the coercion is not written, but is still returned as a result of the assignment. Because assignments can be made to the left or to the right, the C language terms L value and R value are inappropriate. Instead, destination value or D value and source value or S value should be used instead. A handy feature of the right read before write assignment operator is that values can be shifted or rotated to the right between variables. This flexibility makes the intent more clear when a shift or rotate in the opposite direction was performed earlier using left read before write operators. So far we have discussed 5 different assignment operators. With all of these operators, if the source data type is different from that of the destination, an implied conversion will be attempted. If a suitable conversion is not defined, a compilation error will be flagged. If conversion is performed, overflows and underflows are simply lost as in C, unless captured by one of the ancillary operators, which is a feature exclusive to Phi. Allowing overflows to happen using these unbounded assignment operators is not suitable for many applications in which a variable must always have a value that is closest to being correct. For when overflow occurs, at least for the standard integer types, the value wraps around and can land anywhere within the range of the data type. In some applications, the bounded assignment operators are more appropriate to obtaining the most accurate result. There is one bounded assignment operator for each of the 5 unbounded assignment operators. They look the same except they have bars above and below their symbols. When a bounded assignment operator is used, values that can't be stored in the destination data type are limited to the nearest value that can be stored in that data type before being written. For example, a value of hex 1693 might become hex FF when the destination is only 1 byte in size. Potentially both values can experience overflow when the swap assignment operator is used. Here, 2 implied bounding operations may be performed. To control bounding that happens in a swap, you might consider using a mix of bounding and unbounding assignment operators in a more complex expression. So here are the 10 assignment operators in ϕPPL. The few simple rules I have discussed should make an appropriate choice of an assignment operator easy to make for the intended purpose and give you greater control over your application. This concludes our discussion of assignment operators in the Phi parallel programming language.